You are watching the Control Design educational video series, Automation Basics, HMIs. This video is brought to you by our sponsors, Beckhoff and Schneider-Electric. More information on our sponsors will be provided later on. You can also find company and product information provided in the information section below.
The definition of human-machine interface, HMI, is wide-ranging. Certainly anything with a graphical display that an operator can interact with can be called an HMI. Even a one-line alphanumeric display can be an HMI and can display operator-selected information such as fault messages or production counts. In many cases, when the HMI is specified, the HMI software is chosen by default. It comes with the hardware. Although many vendors require the development software be purchased separately, the HMI is often application-driven, and there is a lot of overlap in the choices available. An HMI includes both display hardware and software typically offered by an operator interface terminal, OIT, embedded PC, or PC-based. Often the hardware selection drives the software development platform used. It's not until the decision is made to go with a PC-based HMI that the HMI software possibilities open up. For small applications, focus on the HMI hardware's functionality and cost. Some important requirements for the small displays are screen size, color versus black and white, and resolution. If just a few variables, counts, and set points need to be monitored and adjusted, and a couple buttons are needed for minor control functions, size your HMI screen size appropriately. It doesn't pay to get a larger display or to spend time on fancy graphics. While the OIT may have limited protocol availability and features, it may still provide a built-in web server enabling remote access to some of the data and may even have data logging, but limited memory to do so. As the machine application requirements move to more graphical screens, buttons, alarm history, recipe functions, trends, and historian functionality, such as those commonly offered by the PLC vendors, HMI software functionality increases. These middle-of-the-road HMIs, usually embedded PCs, still closely tie the HMI hardware and software together. Typically, the software is configured and written on a development PC and then downloaded to the HMI, with each HMI including the runtime. With the HMI and PLC from the same vendor, the software for the HMI may use the same development platform as the PLC programming software. Although it is happening at all levels from the basic OIT on up, it's at the PC-based HMI software level where edge devices and controllers are being tied to the Internet of Things. This is the HMI SCADA level where the software can take advantages of the resources in a PC, such as more memory and storage capability, significant connectivity, and strong graphics capabilities. If you need more, just upgrade, add to the hardware, or add PCs and runtime licenses. For the historian, database connections, reports, and remote access, the PC-based HMI software provides OIT and cloud connectivity, which enables analytics with big data. The HMI can even reside in the cloud along with the data. When it comes to developing graphic screens, there are many basic HMI design techniques that should be followed, but an operator interface is more than just a pretty picture. That pretty picture may have too much information. Be sure to create logical zones on an HMI screen and limit these zones to 5 or 7. Create columns or put boxes around each zone and include clear, large text to identify it. Limiting the number of colors used and simplifying the navigation can also make for a better HMI. While HMIs have dozens of screens, focus on machine or process status, fault indication, mode control, recipe or set point adjustment, and manual functions. The HMI software is not just about monitoring things such as machine status, graphical displays, alarms, variables, and mode control on a machine or system. It's also about using the HMI and the data to make decisions. While the HMI software can scale up to monitor and control large machines and processes, it is also shrinking back down to edge devices controlling small machines and process skids. In this case, the HMI software is mated to the machine control software on the same mini PC, no bigger than a deck of cards. While the HMI software is installed, there is no HMI hardware, but the included Wi-Fi connects the controller to the HMI in your pocket, the smartphone. Since an HMI is a possible ignition source when used in a hazardous area, consider mounting it in a safe area. If not, the HMI specified must be clearly marked with the certification for use and the area classification. For example, ATEX Zone 1 and NEC Class 1 Zone 1. The manufacturing or processing facility is required by law to classify the explosive area. The material used in the construction of the HMI need to be immune to any chemicals present in the atmosphere as well. If not, the display faceplate is likely to become hazy or the housing may soften, and personal protective equipment such as gloves may make it difficult to operate a small display, so a larger screen should be considered. Alarm indication is important in HMIs and is generally broken down into at least 3 categories. Immediate stop alarms are conditions that indicate unsafe conditions that stop or require the machine or process to be stopped immediately. Examples include emergency stops, open gates, loss of power to some sections, circuit breaker trips, or sensor and actuator errors where the machine cycle or process cannot complete. A cycle stop alarm will allow the machine to complete the current cycle, but not allow another one to begin until the cause of the alarm is addressed. Low raw material, some conveyor jams, motors starting to overheat, or specific operations taking slightly longer than expected are examples. Warnings occur when a condition that should be addressed exists, but the operations can proceed without damage. Hoppers getting full, excessive blocked or starved times, or low oil pressures caused by plugged filters are examples. Pounding on the emergency stop is likely in an emergency situation. It cannot be a button on the HMI screen. Safety standards require it to be a hardwired push button. Some will argue, with the advances in HMIs and computer graphics, that machine power on, power off, reset functions, and all fault indication, machine status, and operation can be provided on screen. While the HMI can do it all, except the emergency stop, it's not always the quickest or most robust method of operation during production. Sometimes the use of push buttons that are poked often, and indicator lights, stack lights, and alarm horns are better options. These devices can greatly reduce the response time to a machine fault condition and provide machine status information at a glance or without looking. HMIs can do a lot now. They can collect data from many dissimilar items, filter it, push it to the cloud where analytics can happen, and send valuable information back to the user. They are providing actionable data more quickly than ever before. The analytics and artificial intelligence will add much information. For well over 40 years, HMIs basically provided data communication, manipulation, and presentation. The same concept exists today: read data, manipulate data, and present it. A big change is how information is presented and how we interact with it. Smartphones and tablets are just the start. Microsoft Halo, Apple Watch, and Google Lens will only improve the data presentation. HMIs still collect and display the same information they did in the past, but they can do so much more, and they will become simpler and more efficient for the future workforce.
Beckhoff, the comprehensive portfolio for world-class HMI, with multi-touch HMI hardware, countless display screen options, and mobile-friendly HMI software. Visit Beckhoff.com to learn more. Schneider-Electric. Discover the customization possibilities by improving the design of your machine and optimizing your operator interfaces. Products include push buttons, legend panels, and switch options. Learn more at www.se.com.